Okay, next we have energy of a point charge distribution. Suppose we have 3 points. We have 3 point charges which are far away from each other, like they are at infinite distance from each other, and we are bringing those 3 charges somewhere here to this point. Let's suppose charge 1 is somewhere on this way, charge 2 is somewhere on this way, and charge 3 is somewhere on this way at infinite distance, and we are bringing those point charges close to each other. Now then, how much energy we need to assemble these 3 point charges, we will calculate that one. I can say that one point is here. Let's suppose we have one point is here, one point charge is here, and 1 point charge is somewhere here. These are the 3 point charges. Let's say this is Q1, this is Q2, and this is Q3. And I assume that these distances are infinite. They are infinite far away from each other. So they have no interaction, whether there is no attractive or repulsive forces of these 3 charges on each other, because this distance or this distance or this distance is too much. It's infinite. Now what we are doing, we are bringing these 3 charges to somewhere in this position, in this point. Then how much energy we need to assemble these 3 point charges, we will calculate that one now. Now we are bringing this point charge to this region from here to this point here. Since there is no other charge present in this region, so it means that the work done in bringing this point charge from infinity to this point, which is, I call it R1, and this is the path of the charge Q1. Then the work done, W1, and bringing the charge from this point to this point is 0, because there is no field present. To fight again, we will do work done against the field. Like in the previous case, we consider this situation. Yes, we have already charges present here, and we bring this point charge from here to here, so we were fighting against the electric field of these point charges. But here there is no such kind of charge present at this region, so we are bringing this charge in a free space, in a free environment, so the work done will be equal to 0. Now next, what we are doing, we are moving charge Q2, this charge Q2, from infinity to somewhere here. So we are bringing this charge Q2 in this path from here to this point, and I call this point is R2, such that if I bring this point charge from here to this point R2, the distance between these 2 point charges is R12. Now the work done will be W2. Work done in bringing this point charge Q2 to position R2 will be W2, which is equal to bringing the charge Q2 in the field of charge Q1, where V1 R2 basically represent the field, the potential field of this charge Q1. This is charge Q1 now at point R2. So the work done will be this one, because we already calculate this relation, W is equal to Q into V, where Q is the test charge, this is the test charge now, and V is the potential of field of source charges, where V is the field of these source charges. Now here the source charge is Q1, and we are bringing this charge to this one, so the source charge field at point R2, so that's why it is V1 R2. Now we know that the potential of charge Q1 at point R2 is, since potential of charge Q1 at point R2 is 1 over 4 pi epsilon naught Q1 over R12. That is the distance from this point charge to this. So we have worked W2, which is Q2 into 1 over 4 pi epsilon naught Q1 over R12, or W2 is equal to 1 over 4 pi epsilon naught Q1 Q2 over R12. What we are doing next now, we are bringing the third charge from infinity. This point is at infinity, okay, with respect to this region, to this point here. I call it R3. Now, what will be the situation? The situation is simple again. We will do work done in bringing this charge Q3 from this infinity to this point. So the work done, I call it work done, which is W3. Now this work done, if I bring this charge to this one, then there are two potential now. One potential is due to charge Q1 at this point, and the other potential is due to charge Q2 at this point. So we have again the same expression like what we did for this one, because if once we bring charge Q2, there is one charge. So we have Q2 times potential of charge Q1 at point R2. Now we are bringing charge Q3, so it will be equal to Q3 times potential of charge Q1 at point R3 plus Q3 times potential of charge Q2 at point R3. Now this distance I call it R23, and this distance I call it R13. So it means that now V1, potential of charge Q1 at point R3 will be V1 R3, which is equal to 1 over 4 pi epsilon naught Q1 over R13. And similarly, potential of charge Q2 at point R3 will be equal to 1 over 4 pi epsilon naught Q2 over R23. Now using this value in this equation, we get W3 is equal to, we have Q3 and Q1, so we have 1 over 4 pi epsilon naught Q1 Q3 over R13 plus 1 over 4 pi epsilon naught Q2 Q3 over R23. Now the total work done will be, the total work done in assembling all these three charges in this configuration, this region, will be W1 plus W2 plus W3. So W is equal to, W1 is 0 here, W1 is 0, W2 is given by this relation, so W2 will be 4 pi epsilon naught Q1 Q2 over R12 plus W3 is this one, 1 over 4 pi epsilon naught Q1 Q3 over R13 plus 1 over 4 pi epsilon naught Q2 Q3 over R23. So total work done will be equal to 1 over 4 pi epsilon is common everywhere, so we have 1 over 4 pi epsilon naught times Q1 Q2 over R12 plus Q1 Q3 over R13 plus Q2 Q3 over R2 3. This is for collection of 3-point charges. If we are bringing 3-point charges close to each other. Now if I bringing 4-point charges, then again the symmetry is same. So for 4-point charges, the work done will be 1 over 4 pi epsilon naught. It will be a lengthy expression. So there will be a total of 6 such kind of expression. I will write it here. Q1, Q2. Divide by something, I will write that something later. Plus Q1, Q3. Divide by something. Plus Q1, Q4. Divide by something. Because we have 4 charges. Plus, next we have Q2, Q3 divided by something. Plus Q2, Q4 divided by something. Plus Q3, Q4 or something. So if we look at here, Q1, Q2, there is R12. Q1, Q3, there is R13. So Q1, Q2, we have R12, R13, R14. Then we have Q2, Q3, we have R23. Q2, Q3, R23. Then there will be R24 and there will be R34. If we have n-point charges, I can write it for n-point charges. W is equal to one over 4 pi epsilon naught sum over I started from 1 up to n sum over j started from 1 up to n. We have I Qi Qj over Rij. But there is a condition that j is always greater than I. Because 1, 2 is j, 1, 3 is j, 1, 4 is j. I is 2, j is 3, I is 2, j is 4, I is 3, j is 4. So j is always greater than I. Now this is the expression. We can also write it is, now here this j is greater than I is just to remind you that the same term cannot be counted 2 times, because R12 is equal to R21. It is the distance. So if I measure it from 1 to 2, or if I measure it from 2 to 1, it's the same. So R12 will be equal to R21. So same terms cannot be measured twice. That's why I put this condition here. If I count the same term twice, then I have to divide this whole expression by 2. Then it's okay. I will not introduce this one. And also there is one more condition, that j is not equal to I is also included here, because one term is not here. Q1 over R11 square, which is not in this expression. So if I count the same term twice, then this will be equal to W is equal to 1 over divided by 2. So it will be 8 pi epsilon naught sum over I started from 1 up to n, and then sum over j started from 1 up to n, Qi Qj over Rij. Now here we have 2 such kind of terms. One is 1 2 divided by R12, one is Q1 2 Q1 divided by R21. But both these terms are same, so they will add with each other. So we have 2, so that 2 will cancel well this one. So again we have this form. But again we can write that I is not equal to j. So this condition still exists here. Now this is the final expression. Next we will simplify this expression a little bit more. So I can write this is like this: W is equal to 1 over 2 into sum over I Qi into sum over j started from 1 up to n. I also started from 1 up to n, and j is not equal to I. Okay, because we have this condition exists there, and we have Qi Qj, sorry, we have Qj over Rij, but if here we have 1 over 4 pi epsilon is also there. I can write it in the next page. I can write this expression is W is equal to 1 over 2 sum over I Qi. I bring this term with this summation n2. This is 1 over 2, so we left with 1 over 4 pi epsilon naught sum over j started from 1 up to n, and j is not equal to I, and we have Qj over Rij. Now the term in this bracket basically tell us the potential at point Ri due to all other charges. So this can be written as 1 over 2 Qi, sorry, with summation I Qi Vri, where Vri is basically 1 over 4 pi epsilon naught sum over j started from 1 up to n, j is not equal to I, Qj over Rij. So this is the potential at point Ri due to all other charges. So this is the final expression for the work done and assembling endpoint charges. This is the total work done. And assembling endpoint charges. In the next video, we will go towards the energy of continuous charge distribution.